Hello, good evening, my warriors. This is your captain, Shreyas, speaking. After a successful takeoff last week, we have now started to enter the clouds. I hope your seat belts are on because the ride is going to be adventurous. Just sit back, relax, enjoy this journey. The view is beautiful, plus bumpy. So get ready, guys, with your master teacher, Shreyas, on your screen, live. Hello, everyone. Hello, Nancy, Priyanka, Minion Aarti. Hello, Nirmal. Hello, Chaturya. Hi, Tehnyat. Hello, Srinu. Hello, Nirmal. Hello, Vishal. Hi, everyone. This is Shreyas here, your master teacher. And I not only teach on Enthuse channel, but I also teach on the regular paid platform. So many of you probably would already be in the pro subscription, and if you're not, yes, I'll tell you more about it towards the end. So you will find me there in lots and lots of courses. Hello Jayvant, hello Andrew, hello Samiksha, hello Kushali, hello JEE 22 aspirant, hello Ankit, hello Adityan. Welcome aboard. How is everyone? Good evening, good evening. Nice to know, Abhishek, you are super duper excited. Same here. Even I am super duper excited. So guys, those of you who do not know me, I have been training kids for a very long time, and a lot of my students are now in IITs and NITs. So I'm pretty sure your aim is also to reach IIT, and if it is not, you better make it your dream, guys. Any one top college should be your dream, and you have to work for it, because if you don't have dream, you won't know what to work for, how to work for it, unless you have an ambition. So guys, make up your mind, create a dream, put it up as a sticker in front of your wall, in front of your bed, so every time you move around, it's there in front of you. So I surely want you to be in all the top prestigious institutes in our country. Welcome aboard. And if you want to know more about me, you can definitely follow me on my Instagram handle, that's Shreyas_Vedantu. And before we begin the session, I hope you have already liked it, and in case you haven't, go smash that like button down there. Yes, show us your love, show us your support. And if you are new to this channel, do not forget to hit the subscribe button, because unless you hit the subscribe and the like button, YouTube, the way it works is that it won't recommend you all our videos. So do that. Hi Namika, hi Jayvant, hello. I will definitely talk about my experience at NIT Adityan. In fact, those of you who are new, I in fact started something called as Coffee with Shreyas, which is basically casual talk sessions where you guys keep on asking me doubts and I share my experiences. Definitely I'm going to conduct one such session again. All right, so stay tuned, guys. Yes, Coffee with Shreyas is definitely coming. Vikram already said, IIT Bombay, I'm coming for you. Very good, very good, very good, very good. Yes. Oh my God, Vijay Kumar actually smashed his tab into pieces. Oh, RIP Vijay Kumar. Laptop or whatever, tab. Yes. So Mohammad Irfan, don't worry, Wazim sir will tell you about all the books for chemistry. All right. So I'm a physics teacher, but you know, I think Shimon sir also conducted a class on the books which are supposed to be used for all the three subjects. Please go ahead and watch it because it is there in our past videos. All right. So please do that. And a lot of you are asking, sir, what is the timetable? So here it is, guys, for this week on this channel. This is just the weekly timetable for now. Today we are doing kinematics. So we are going to talk about, so what are we going to talk about today? So in today's class, we're going to talk about graphs. We are going to talk about the free fall motion, and we are also going to see some problems on the kinematic equations, the three kinematic equations. That's what we're going to see. Now this is a very interesting lecture, quadratic and algebra. You're going to see a lot of new formulas. You're going to learn how to use graph software, the graph software. That's what you're going to learn, guys, and a lot of new formulas, and you're going to see how to use quadratic equation in physics. How will you use it? What is the use of all algebra, quadratic equations in physics? That's the timetable. This is on Friday. Today, Monday, 7:30, we are going to do kinematics. So 7:30, basic maths and physics. So keep that in mind. Do not forget it. All right. And as we go ahead, we are going to slowly increase the frequency of the classes as well. But for now, I'm pretty sure you would have at least 6 classes from physics, chemistry, maths to keep you occupied for the entire week. All right. So, Lena, Wasim Sir's Pro batch is starting on 3rd of May. So, Wasim Sir's batch is starting on 3rd of May. And then you have Shimon Sir's batch, which is starting on 10th of May. I am right now teaching in 12th, but a lot of my micro courses are going to start. In fact, you can see them even right now. You can see a lot of my micro courses. I'll tell you what is micro course in a bit, but a lot of chapter wise micro courses are there even now in the 11th Pro subscription. Okay, and I'll be taking up a lot of classes in the coming weeks ahead. All right, so let's also begin our today's class. Yes, and Nirmal, I already did a JEE 2021 strategy video, and I think Shimon Sir did it, sorry, and JEE 2022 I did it just last week. Okay, yep, Shimon Sir's batch will start on 12th. So guys, yep, gather all your dreams, because yes, you need to start preparing from right now, because unless and until you don't start now, you're going to be late in that game, and it's always better to have a head start. So understand, 2 years is the perfect time to prepare for JEE, NEET and all these competitive exams. If you are prepared before this, some kind of foundation, etc. on 9-10 channel or through Vedantu, that is definitely going to help you. It's going to be like a boost. But please understand, those of you who have not even taken foundation or any kinds of courses, it's okay. 2 years are enough, because even I cleared my IIT within 2 years. Okay, so you don't have to worry or think, oh, is 2 years going to be enough? Don't worry, there are people who clear in 1 year also, but they are very hardworking then. So you don't really want to risk that 1 year and chill out in 11th and then start preparing in 12th. So you guys need to start preparing now itself. So this year also, I'm pretty sure you're going to study online itself, because I don't think the situation is going to improve so much outside. You know what's happening outside. Plus, you know what do we offer, and on our Vedantu platform. And in case you don't worry, I'll tell you everything about our Vedantu platform as days progress, as lectures progress. So we are going to offer you all kinds of learning, alternatives. So those of you who want to study on YouTube, yes, we are going to be here. Those of you who want to study under Pro subscription, that alternative is also going to be there. So those of you can not afford Pro subscription, yes, you guys are obviously welcome on YouTube. And those of you who can afford Pro subscription, please go ahead, check out the link in the description box below, and you will see all the features which are there in the Pro subscription. All right, I'll be talking about it in the end. So let's begin today's class. Yep, let's begin. Okay. So today's topic, Jevan, today we are going to talk about, kinematic equations, the free fall motion, as well as, the graphical questions as well. All right. Okay. So let's begin, guys. Are you guys ready? Put a yo in the chat box. Are you guys ready? All my warriors. Oh my God, Anish, I saw your DP. Very good. Very good, Guhan. Very good. Anish, very good. Okay, Yalni also is there. Monkey, D. Luffy, Rajaram, Raja, Sozan. Oh my God, what names? Crazy. Samarpita Chaudhary, Archana. My God, I can see already so many people have already changed their DPs. And in case you haven't, please change it via the channel art link, which is there in the description box below. Okay, before we go ahead, let me show you some very interesting thing. Last time, yes, if you just go to the past videos out here, okay, and I conducted a class few days back, and let's just look at the comments. Please don't give me advertisements on food. I will feel hungry. Stop it, YouTube. You know me too well. Okay, so let's just have a look. Wow, thank you, Harshal. Yo. And Samiksha says B. Very good. The correct answer was indeed B. Leena, very good. The answer is B. And then Shankar, the homework answer is B. Very good. Shruti, slight mistake. It's okay, but you attempted and you commented. Thank you so much for loving it. Oh, in fact, let me also love the comment. Okay, so the answer of the Shreya Kumari. Yes, very good. Very good. And Ankit has asked something. I have replied. Very good, Adarsh. Excelente. And then we have Tanmay Shukla, B, very good. Samarpita, very good. So many people answering it. Okay, I'll just reply to all the comments. I'll just say hi. And very good, Nanda Kishore. very good Jaya Ji, very good Marasamy, very good Jaideep Naidu, and very good Sharwin. Excellent, very good, excellent, loved it. Yes. So let's begin. I'm going to show all those people who are going to post a comment on our videos as well for the next time. So stay tuned for today's homework. Now let's talk about the motion in horizontal direction. All right. So remember, kinematics is the study of motion, how it is happening, not why it is happening. So let's say there is a car which is accelerating, maybe there is a animal which is chasing something else, maybe your mom is running around you with a chappal to hit you. All right. So your mom is accelerating, she's having some displacement, and you want to study her motion. How much is she accelerating? How much time will she take to reach me? With what velocity is she going to throw the chappal at me? So these are to be understood via three simple equations, and those three simple equations have a specific condition. They have a specific condition. And what is that condition? Constant acceleration. So unless and until, understand, the acceleration is constant, you cannot use the following three equations. So yes, Sudhir, the link is in English only. I teach in English in all the micro courses, let me tell you that. So whatever micro courses you will see of mine, I am teaching in English. The three equations are V is U plus AT, yes, S is UT plus half AT square, and V square is U square plus 2AS. So guys, what is U? What is the meaning of U? Come on, type it out in the chat box. What is U? What is U? In the chat box, come on. Come on. Think. What is U? Rajaram will definitely do that. Definitely, but now is not the time. We'll make it later on. Okay. Yes, initial velocity. What is V? What is V? What is V? V is, oh my God, who is that? Acceleration. V is final velocity. Very good. And A is acceleration, S is displacement, T is time. So these equations will help you solve some problems. Let's get straight away to problems. I think you will be able to solve at least the starting part, and slowly the problems are going to get tougher now. Okay, let's see this. A racing car is moving with a velocity of 20 meters per second, applies brakes and moves at a rate of 5 meters per second square. That means it decelerates. It decelerates at 5 meters per second square. What will be the braking distance is the first question. The second question is, what if the speed was double? Let's solve the second part later on. First, let's solve the first part. So first of all, whenever you get such questions, remember, though this is a simple problem, I am teaching you the technique. Follow the technique, because for simple problems, it might look unnecessary. But then when difficult problems will come, you will find it necessary. So that's why I'm showing you the proper method. So show everything. Initial velocity 20 meters per second. It is decelerating, so acceleration is 5 meters per second square. Usually I will use double arrow mark for showing acceleration, usually. Okay, and finally it comes to rest, and the question is, how much is the braking distance? S. So obvious equation that we should use is nothing but V square is U square plus 2AS. Final velocity is 0. Okay, initial velocity is 20, so square it, plus 2 into acceleration is negative because it is retarding, so minus 5 into S. So therefore, take this guy on the other side, so 2 5s are 10, so 10S is equal to 20 square is 400, so therefore S is equal to 40 meters. Let me just turn back and see the chats. Who and all have answered? Who and all have answered correctly? Yes. Ooh, Andrew, very good, monkey, very good. Excellent. Very good. Okay. Now, this is done. Now, let's see what should be the answer for the second part. Come on, who can orally tell me what is the answer? What do you think the distance to brake will be if this speed was double? If this speed was double, what do you think the braking distance will be? Easy. Now, wait. Wait, now you will see the next part. If the speed was double, what do you think the braking distance will be? Will it be also double or no? 160, 20, All right, very good. You guys are smart. So the only thing that will change is instead of 20, you will put 40. So 0 will be equal to. So this same thing, it will be 40 square plus 2 into minus 5 into s, and you will get 10s is equal to 1600. Therefore, s is equal to, yes, 160 meters, which is 4 times. This is interesting. Look at that, 4 times. Now this is why accidents happen. When you double your velocity, you think the braking distance should double. And that's what generally drivers do. Have you not seen that? When the speed is low, they maintain a distance. When the speed doubles, they just double the distance. Some drivers have very nice talent. They are very talented. When their speed increases, they go closer. They get a lot of confidence. I don't know from where. Usually I have seen drivers, they go a little bit behind, but not so much. Actually speaking, when your speed doubles, you should go 4 times more to be safe. Keep this in mind. Else, the chances for accidents will increase. I hope this is clear. Okay, cool. Yes, somebody said they put CR tires. Yeah, no matter what you do, guys. So, be safe rather than being sorry. So that was the answer. All right, let's get going. 40 meters. Cheetah question. Cheetah looks at a deer and accelerates to a velocity of 20 meters per second in 10 seconds. Find the distance for which it accelerates. Come on. Let me know which equation are you going to use. Let me know which equation are you going to use. Is this 1D motion? Yes, Nikhil Kiran. We are starting with the bridge course. We are revising all the concepts. I'm teaching you few new techniques. You are going to be at the same level before we start the actual course. This bridge course is mandatory for all the 10th to 11th moving students, so that, yes, for all the 2023 aspirants, because guys, unless you do the bridge course, you will find the actual course to be a little bit difficult. So that's why you need to step on this bridge course and only then climb up the ladder. All right, second equation, let's see that. If I use second equation, S is ut plus half at square. The problem is I do not know A. I do not know A. So I need to find out A. Maybe I can use V is u plus at. Maybe I can use that. So from V is u plus at, final velocity is 20. Initial velocity of the cheetah is 0. Acceleration, I don't know. Time is given. Time is 10 seconds. From this, acceleration will come out to be 2 meters per second square. I will need 2 equations to solve this question, guys. Now use the acceleration over here. So S is initial velocity, obviously 0, plus half into acceleration is 2, and time is given to be 10 seconds. So 10 square. So distance will be 100 meters. So that's the answer. Is that now clear? Yes. Yes, I hope this is clear. 100 meters, understood? So 2 equations are needed because A was not given. So sometimes you might need 2, sometimes you might need 3. Depends on the question. Enjoying it already? Clearo? Clearo everyone? Clearo? Okay, if it is clearo, please do not forget to smash that like button down there and then we'll go ahead. Okay, let's get going. 100 meters, beautiful. Now, next question. A Pandu, wow, Pandu sitting in the car. Pandu accelerates the car at 2 meters per second square starting from rest. And as soon as he reaches the top speed, he brakes at 4 meters per second square till he comes to a halt. The total time taken is 10 seconds. What is the maximum speed reached by the Pandu's car? Thank you, Jai Tripati. How to find the equation for the question? Archana, see what is given. V is given, U is given. Whichever is given, like whatever quantities are maximum, try to use that equation. Let's say V is given, U is given, and A is also given. Where are these 3 variables present? First. So that's how you will figure out. Is that clear? Yeah, Pandu is back. So first, let's draw the situation because it doesn't look like a very easy situation to me. Let's see this. Straight road. This is where Pandu starts. Okay. So he starts from rest. And this is at t is equal to 0. Cool. Now he gets maximum velocity. I don't know how much it is. And again, after some time, he stops. He brakes and he stops. This is how much time? 10 seconds. This is 10 seconds. This is the problem. Now, it is clearly mentioned in the question. He accelerates. Remember, acceleration I usually show with 2 arrow marks. He accelerates with 2 meters per second square and he brakes. So that's why see the arrow mark. While accelerating, you are accelerating the same direction as you are moving. While decelerating, your acceleration is opposite to the velocity because your speed is decreasing. So that's why it is 4 meters per second square in the opposite direction. Let's say from here to here, the time taken is t1 and from here to here, the time taken is t2. Is that okay? I hope you notice that I do not know the values of t1 and t2. This is very important. Why I don't know? See, the total time for the motion is given 10 seconds. They didn't tell you he accelerates for 5 seconds and decelerates for 5 seconds. I hope this is clear. You just told total time is 10 seconds. The problem is the acceleration's magnitude and the deceleration's magnitude is not the same. That means the time taken for acceleration and time taken for deceleration will also not be the same. Acha. So then what do I do? When you see that the acceleration changes, mark my words, when you see the acceleration changes or situation changes or the event changes, divide the complete event into smaller events. How many events do you think you can divide this problem into? How many events do you think you can divide this problem into? Yeah, sure, Kirito, no problem. Hello, Chiranjeev Sujay, welcome aboard. 2 events. Now the best part is the final velocity of the first event. The final velocity, which is the v value of the first event, is the initial velocity of the second event. Agree or disagree? The final velocity of the first event is the initial velocity of the second event. Agree, guys? Agree with this? Yes? Understood? Clear? Yes? Is that clear? Very good. Now, which equation should I use? V is u plus at. S is ut plus half at square. V square is u square plus 2s. I can see the displacement is nowhere in the picture. There is no s over here. That means I will not use second or third equation. I feel we'll use v is u plus at. Because s is not there. What is the point of bringing s unnecessarily? So I would say let's use v is u plus at equation. Now see how it works. For the first event, final velocity is v, initial velocity is 0 plus acceleration is 2, time is t1 only for this part. Rearrange it, you will get t1 is equal to v divided by 2. Correct? Time is v divided by 2. That's what we got. Now let's do it for the second event. Final velocity, he stops. That means 0. Initial velocity is v. Okay, that's the initial velocity. Okay, plus acceleration is opposite. That means it should be -4. And time from here to here is taken to be t2. Okay, now shift this guy on the other side. So 4t2 is equal to v. Therefore, t2 is equal to v by 4. That's it. Now, you will be wondering, sir, what did you do now? I wanted to find v. You are not finding v, sir. Yes, hold on, my warriors. We have just framed 2 equations so that we can find v. How? Think about it, guys. T1 is time from here to here. T2 is time from here to here. Total time is 10 seconds. Correct. T1 is not equal to T2. T1 plus T2 is 10. Be careful. T1 plus T2 is 10. So use that. So let me write it over here. Okay, with some other color. Okay, so T1 plus T2 is equal to 10. T1 is V by 2. T2 is V by 4. Excellent. Now what? Take V common. Alright, take V common or just do LCM, guys. This will become 2V plus V divided by 4 is equal to 10. 2V plus V is 3V. 3V by 4 is equal to 10. Therefore, think about it. V will be 4 tens are 40 divided by 3. 40 divided by 3 is 13.33 meters per second, and that is our final answer, maximum speed. Done, done, done. Done, done, done. Isn't it an amazing Go problem? Did you love this? How to solve it? So we went step by step. I didn't just do random things. I thought at everything. Which equation should be used? Why not that? I divided the problem into 2 events. I did not panic because, oh, we are not getting in one equation. I framed more equations till I got sufficient equations to solve that. That's what it is. Okay? Great, great. Let's get going. So the answer is 13.3 meters per second. Amazing Go. Yes. Now, I want to start discussing free fall. I want to start discussing free fall motion because you guys are now in the mood. But before that, let me also make a small announcement. Guys, you're going to find me in lot of micro courses. Let me just make that announcement 1 second. Yep. So these micro courses are something which you're going to find on the Vedantu platform. And these are small chapter-wise courses or book courses or problem-solving courses. You will find me in many micro courses. Example, H.C. Verma discussion. Just search for it, you will get it. H.C. Verma discussion. Then you are also going to find me in I.E. Irodov book discussion. You are also going to find me in derivations. Derivations of all the formulas. All the formulas of 11th standard, you are going to find me here. Then numerical problems. Very, very interesting, tricky numerical problems. You're going to find me there as well. And lot of chapter courses. Plus, let me tell you, these micro courses are free of cost once you're in the pro subscription. Yes, please understand it's free of cost. So do not forget to check out the link later on. And please remember that whatever we teach you over here, alright, whatever we teach you over here, the PDF of that is also available for you guys to download from our Telegram group. In case you haven't checked the Telegram group, please check that because it's there below. Please join it as soon as possible so that you do not miss any updates. Now, let's do a question, guys. Let's do a question. Okay, here it is. A bus starts from rest and moves with constant acceleration 8 meters per second square. At the same time, a car which travels at constant velocity overtakes and passes the bus. After how much time and what distance does the bus overtake the car? Let's do this. Very interesting question. Now, first let's analyze it. It's not so simple. Let's think what is happening. Okay. First of all, let's draw the bus. Where is the bus? The bus is here. Okay, the bus is here. Okay, this is the bus. What is it doing? The bus starts from rest. Okay, that means it is stationary. It is at rest at t is equal to 0. And it accelerates. With what rate? It accelerates at 8 meters per second square. Okay, it accelerates at 8 meters per second square. Now, next thing, there is a car which travels with constant velocity. Now, as soon as the car overtakes the bus, as soon as the car which is traveling with constant velocity overtakes the bus accelerates. The car, meanwhile, is always going with the same velocity. Okay, keep this in mind. Okay, just 1 second. Let us just draw it. Okay, so this is our car. Okay, beautiful car. And it is going with constant velocity of 16 meters per second. And this is constant. I'll just mention it. Guys, as soon as the car overtakes the bus, understand the bus accelerates. The bus accelerates, okay? The bus is behind the car. The car fellow will look behind and be like, oh, the bus is behind there. Okay, it's at rest. But do not forget, the bus is going to accelerate. It's going to increase the speed. And eventually, it's going to reach where the car is. It's eventually going to reach where the car is. So the question is, After how much time will it overtake? So somewhere or the other, both the car and the bus, will have what as the same thing? The car and the bus will have which quantity similar to each other? Think about it. What will be same for both the car and the bus after some time? Think about it. Okay, some of you have already started answering. Velocity, na Rajara. No, Abhishek, no. Displacement, correct, not velocity. In fact, understand the car, as soon as it overtakes the bus will be behind, the bus will catch up, it will accelerate and it will zoom past. It will zoom past the car, and while it will be zooming past, understand the speed of the bus will be more than the speed of the car. Yes, the speed of the bus will be more because it is overtaking the car. So car will be going at constant speed and the bus will overtake it. That means its velocity will be different. What will be same is both of them would have moved by the same amount. Yes, the displacement will be same. So I'll start my equation by saying displacement of the car should be equal to the displacement of the bus. Now guys, what is the displacement of the bus? Ut plus half at square. U is 0. Half acceleration is 8 into t square. I hope this is clear. U is 0, half a into t square. That's why I always draw the diagrams. But for car, the velocity is constant. The velocity is constant. Think about it. If the velocity is constant, when you use s is ut plus half at square, u is 16, time is t, half into at square term will be 0. So understand there is no acceleration. So half into 0 into t square. That 0 is because the velocity is constant, acceleration is 0. Is that clear? Is that clear? I hope this is clear. Yes. Now bring this equation over here and see what happens. So this will become 16t is equal to 8 by 2, 4t square. Oh, this is simple. 4 and 16 goes like this. This t and this t goes. So what are you getting? You are getting t as 4 seconds. So you got the first answer. And then the distance traveled by any one of them will be 16 into t, you can say 16 into 4, which is 64 meters. You use this or that, you're going to get the same answer. Yep, that means the answer should be option A. Is that correct? Understood everyone how to solve the question? I've explained it each and every step, how to solve it, why to do it. So the car overtakes the bus is at rest over here, the car overtakes it and the bus follows and they meet at the same point. So they'll meet at the same point somewhere. So the bus starts after the car has moved and they meet at the same point. So their displacements are same. I've just used second kinematic equation. Very good. Now let's get going to the next question. Okay, I just showed you about the micro courses and all that. Okay, now let's talk about free fall motion, guys. Let's talk about it. So a lot of you would have probably felt this in your sleep, that you're falling down from somewhere. How many of you have felt that? Yes, Neha, you can also solve it using relative concept as well. Yes, but since I have not yet taught relative motion, that's why I'm not doing it by relative motion. How many of you have felt that? VK Veera says, Chiranjeevi says, Archana also says yes. Oh my God, Abhishek says always. Neha says okay, yep. Shreyas Kapri, Vinyan Ardi, Anish, Savikshna, oh, many of you. In fact, it's said that Einstein usually fascinated the feeling of falling from a lift or falling from a tall tower, and he thought that was the best feeling because you get that feeling of weightlessness, just like this dude falling freely, but you cannot fall freely for a long time, all right, because that would be your last fall. Yeah, so basically I understand this is a very weird feeling, but you should never experience it. And some of you might have also experienced it when you are in a roller coaster ride or in a giant wheel, or somebody who is a reckless driver drives over a hump and the car flies in air for some time. So when the car flies in air, or the bus flies in air, or the bike flies in air, for some time you feel weightless, as if you are very light. You would have felt that. So understand, let's talk about free fall. So free fall is nothing but the motion under gravity is called as free fall. Like this pen, I drop it, free fall. I throw this pen up, free fall. I throw this pen at an angle, this is also free fall. I throw this pen like this is also free fall. Don't think free fall means it should fall down. That is wrong. Free fall could be even this, the motion of this pen going up, because only gravity is influencing it. So the motion which is influenced by gravity, that is called as free fall. My God, Chaturya fell down from his bed. Poor Chaturya's bum. Okay. I hope you have moved at your home, and I hope you are fine, Chaturya. Okay, please don't do that again. So hydrogaming, I just said the motion of any object under the influence of gravity is called as free fall. Now, I hope you have also seen or probably studied that experiment where Galileo and others have performed this, where the acceleration of different masses is same, irrespective of what their size is or irrespective of what their mass is, unless and until there is air resistance. So in vacuum, all the masses accelerate by the same amount. So if I take this pen, and if I take, who is there over here? BTS boy, my God, we take BTS boy is, let's say, heavy, he's big. So this is BTS boy, okay, and we take this pen, and this is the pen, and this is BTS boy. I don't know, okay, maybe he looks like this, I don't know. Can you describe yourself? Maybe we can draw a more accurate drawing of you. Both this pen and the BTS boy are going to fall down with the same acceleration, same for both of them, in vacuum. But I don't think that will happen in air resistance. In air resistance, the problem is the resistive force acts in a very weird way. We're going to talk about air resistance in a separate chapter of fluid mechanics, which is a part of 11th standard syllabus. So hold on for that. So for now, all the problems will not include air resistance. Now there are certain important aspects. Oh my God, Sharwin, definitely I'll take you as an example next time for sure. Thank you, Chiranjeevi, for all the wishes, and all the 30K is because of your support and your love. My God, BTS boy is from Korea. North or south? If you say north, then I take back my words. But if you say south, I'm safe, I guess. Is it so? Okay. So free fall motion under gravity. Understand the time taken to go up and time taken to go down is same. Remember this. Okay. Thank God, BTS boy, I'm safe. Okay, so the time taken to go up and the time taken to go down is always the same. Remember this very important property. Next up, when the motion is under gravity, the speed with which the body is projected up is equal to the speed with which it comes back. As it goes, like it comes. So if you throw it with 30 meters per second, speed will reduce, become 0. And again it will increase and become 30. If you throw it with 45 meters per second, it will decrease, become 0, increase and become 45. So whatever speed you throw, the same speed it will come back with. Why? Because energy is not lost. Yes. I hope this is clear. Yep. My God. Nia is from Czechoslovakia. My God, Neha, you can actually spell Czechoslovakia. That's very interesting. And the acceleration of any object under gravity is how much? 9.8 meters per second square on an average. It might vary slightly, but we approximately take it as 10 unless specified otherwise. So usually we take it as 10. Yes, I hope this is clear. Why 9.8? It happens. On Jupiter, it is 24 meters per second square. Yes. On Moon, it is 1/6 of that of Earth. Why? Because the mass of the planet is different. The radius of the planet is different. That's why the acceleration due to gravity on different planets is different. I hope this is clear. Is that understood? Yes. No, Nikhil, unfortunately, I'm right now teaching only in the JEE channel. Okay, so you can attend all my classes, bacha, because the theory is same. Understand? In JEE channel, the objects will fall down at 10 meters per second square. In NEET channel, what will be the acceleration of all the masses? In NEET channel. So when you study in NEET, what will be the acceleration, guys? Please let me know. Please let me know what is the acceleration. Yep. Come on. What is the acceleration? Is it? Yeah. In JEE channel, it is approximately 9.8 or 10. In NEET channel? Yeah, NEET channel also same. Oh, is it? Oh, 1. Okay, 15. Same only? Okay, glad. Okay, great. It's the same. Okay, so it's the same, guys. All the exams is the same. Yep, it's the same. Okay, thankfully. Okay, cool. And what about BitSat examination? I was thinking, I don't know. Maybe we'll have to think about it. And in board examination, I don't know. We'll figure it out. Okay, very soon. Okay, cool. So don't worry, guys. Yes, we're going to figure it out very soon. Let's go ahead and solve a problem. Oh, 3 Pandus. My goodness. Pandu drops a ball of mass 2 kg. After 3 seconds, it reaches the ground. He drops it. The question is, find the height from which he dropped it. Between the symbols of displacement and distance. Samarpita, displacement, it is S, and distance, it is generally D. But sometimes the books might use some different symbols, but that's okay. So they will mention what they are talking about. Yeah, let's do this. Somebody saying 35, somebody saying 45. Oh my God, what is it? So guys, let's think. Initial velocity is 0. Why? Because he drops. Drops means the velocity is 0. It just started. It will accelerate with how much? 10 meters per second square. How much time it took? 3 seconds. It's given. It falls after 3 seconds. This mass is no use, no bhav only. Useless. Why? Because how will it matter? 2 kg, 10 kg, 100 kg, 1 ton, it will still accelerate by the same amount. So this is useless information. So which equation are you going to use? Acceleration is known, initial velocity is known, time is known, you want to find height. Oh, the second equation. S is ut plus half at square. I think everything is there except for S. S is basically the height, that's the displacement. U is 0, half into acceleration is 10, okay, and time is 3. Okay, so what do you get? 3 square, 9, 9 into 10, 90, 90 by 2, 45. So 45 meters is the answer. Done. Clear? Oh my God, look at all my warriors. They have already written down the answer. Beautiful, guys. Excellent. You guys are very smart. Good evening, Pooja Thakur. Welcome aboard. My God, guys, please help Anjali. Raj, suno yaar, ignore kar rahe ho mujhe. Love you yaar, sorry. Hearts. Oh my God. Raj, sun rahe ho. Oh my God, we have couples already on our channel. Very good. No Shri classroom. Please don't do that. Okay? You have to use NCERT as well as HCV. Don't use Halliday and Resnick. Okay? Cool. Great. Let's get going to the next one. 45 meters is the answer. Cool. Next question coming up on your screen. An iron ball and a wooden ball of the same radius are released from the same height in vacuum. They take the same time to reach the ground. The reason for this is, come on. Rajat, I'm very good. Thank you very much. I have heard you are a photographer. Oh, interesting. Yes, I am. I was. But these days also I click photos. But I don't get too much time. Okay. Yes, Mala Mohan, you can definitely start 12th standard subscription now because there is a batch starting this week itself. I think there is a batch starting this week or next week. So yes, you can definitely take up a pro subscription. So there is a link in the description box. Choose your standard as 12th and use my coupon code SHHPRO so that you will get 10% off. Very good. The correct answer is actually A. Acceleration due to gravity in vacuum is same irrespective of the size and the mass of the body. I just discussed this. Very good. Correcto. Beautiful, guys. Next question. Let's do this. A body is dropped from a height of 2 meters. It penetrates into the sand which is there in the ground through a distance of 10 centimeters before coming to rest. What is the retardation of the body in the sand? Let's do this. Let's try this out. Okay. So first of all, the body is dropped from some height. How much height? Let's see how much height. 2 meters. Okay, so 2 meters. So because it is dropped, that means the velocity was 0. And when it reaches the ground, it will have some velocity just before hitting the ground. So this is the ground basically. Before hitting the ground, it will have some velocity. Now, as soon as it starts penetrating inside the ground, the retardation will start, and it penetrates inside by how many meters? Oh, just 10 centimeters. Now, how much is 10 centimeters? It is nothing but 0.1 meter. 10 centimeters is 0.1 meter. So it just goes down by 0.1 meter and finally it stops over here. That's what the question is. Now, for this red journey from here to here, what is the acceleration, my warriors? Come on, think about it. So Anamika and all others who want to ask personal questions and out of the topic questions, do not forget you can also post a comment below the video. I respond to all the doubts and queries. Also, you can alternatively send me a query on this Instagram handle, which is Shreyas_Vedantu. I will reply to you over there. Okay, so let's go with the flow. Yes, it is 10. So the acceleration over here, we take it usually as 10, guys. Usually we take it as 10 unless it is specified otherwise, 10 meters per second square. But here it's retardation. So that's what has to be found. We have to in fact find what is the retardation. Do you see why the A value is up? Because as it goes down, it stops. So it is accelerating opposite to the motion. Motion is down, so acceleration is up because it has to stop. Okay. Now for the red part. Remember, there are two events. First event, second event. The first event's final velocity is the second event's initial velocity. The first event's, the fall motion's final velocity is the second event's when it retards initial velocity. So for the initial part, what can I do? I can use the third kinematic equation, which is v square is u square plus 2as. So v is v, u is 0, okay, 2 into 10 into s. S is 2 meters. Therefore, I'm going to get v square is 2 to the 4, so I'm going to get it as 40. Okay, so v square is 40. Yes. So, Aro kya does? The v is the velocity just before it hits the ground. Once it starts retarding, that v will become initial velocity for that penetrating part. So that is the initial velocity as it goes inside the ground and it stops. So v is not the velocity of ground, bacha. V is the velocity of that ball which is dropped or that body which is dropped. Now for the second part. For the second part, again use the third kinematic equation. Yes. 20 meters per second. Yep. 20 meters per second. No. Pooja Singh. No, not Pooja Singh. Somebody else said 20 meters per second. I'm not sure who said. Guys, understand, no need of finding the value of v. No need to find out the root. I'll tell you why. Because again, if you use this equation, final velocity is 0. Final velocity is 0. Initial velocity is v square. 2 into acceleration, I don't know. In fact, minus a. Why minus a? Because retardation into s. How much is s? 0.1. Now the value of v square is what is 40. So that's why I did not find out the root value, because unnecessarily it will be a waste of calculation. I hope this is clear. So that's why it will be 40 as it is, and this will be minus 0.2a. Now shift this, you will get 0.2a is equal to 40. Therefore, a is equal to 40 divided by 0.2, and that is going to be 200. Yes, 200 meters per second square, guys. And that is option B. Option B. I hope this is clear. Hi Siddhant Chawal, welcome aboard. Jignesh, this is an English channel for all the English medium students. So there is a separate Hindi channel of Vedantu itself. You can definitely go check it out. It's only for English medium. Okay. Is that clear? Is that clear, everyone? Is that clear? Very good. Very good. Understood? Done, done, done. So Rudraksh, whatever doubts you have, you can definitely post it on my Instagram handle. I'll definitely reply, or you can post it below the video. Okay, do that. Hello Shamina Nasreen, welcome aboard. Let's get going to the next question. Okay, yes, that was 200 meters per second. Now let's see some graph based questions. Graph based questions. Okay, let's see how to solve this. Now, whenever I say graphs, people usually get confused and they misinterpret. Believe me, I have planned many lectures on graphs because graphical analysis, drawing graphs, interpreting graphs, graph-based paragraph questions and graphical-based analysis is very important aspect, not just for kinematics but for throughout of JEE NEET syllabus. Now, graphs helps us understand the situation, the the scenario of the problem or whatever is happening, okay, in a very easy manner, unless you do not know how to read the graphs. So if you learn how to read graphs, okay, trust me, it helps us picturize, it helps us infer all those informations, all right, all those bits and pieces in a very simple way rather than to have to write it, in words or in equations. Yeah. Now imagine this female out here, let's just call her Champa, and this Champa, let's see what she is doing. Champa goes from B to A to C, and first she actually starts from A, then she goes to B, and then she goes to C. So look at that, see what Champa is doing, guys. So Champa starts from A, goes to B, and then goes to C. Okay, now if you want to draw that graph, basically what happens, you draw a vertical line, you draw a horizontal line. Okay, there is an origin over here. Okay, so let's do one thing. So I draw a vertical line, I draw a horizontal line. This one, let's say, is time. Let's say this is the x coordinate. This is time, this is x coordinate. Now, when she started the journey from point O. So initially, that means when time was 0. Then the position was also 0. As time passed by, Champa moved till here. So Champa moved till x is equal to 50. I hope you see that as time moved by. As time passed by, the position of Champa also increased till 50. And then suddenly what happened? Champa turned back and came back to point A. That means don't retrace that graph. Remember, time cannot go behind. Time always has to go ahead. So basically, you will see again the graph will come back over here. So this is point B, this is point A again. This is point A again. She started from A, she went to B, and again her coordinates started reducing as time progressed. And then, yes, Samarpita, that is the y coordinate, but that's the y axis. But here my y-axis is the x-coordinate. Understand, the variables are different. It's not, I usually call it as the vertical axis and horizontal axis, not y and x, because y might not, or the vertical might not always contain the variable y. Sometimes you might have momentum versus displacement. Sometimes you might have force versus momentum. So any graph is possible. So that's why I'm saying this is vertical and horizontal axis. Okay, I hope this is clear. X means position, not x-axis. Correcto. I think somebody said it. Wow, Modi ji, thank you. Modi ji is in our channel. Very good. Thank you. Now, after Champa comes back to A, she goes on the negative side. So that means the x coordinate is negative to minus 50, and time progresses and she goes there. Somewhere over here, this is point C. Is this understood? This is how graphs are drawn. Is that clear, everyone? So understand, this graph is not the path taken by the Champa, is not the path taken by particle or the body. It tells us visually, oh, the position increased, decreased, came back to 0 and it became negative. Champa did not actually travel like that. Champa has just gone like that and like this. Understand the difference between the path. This is not a path. This is not the path. But what is it? But it is in fact the graph of position versus time. I hope this is clear. Everybody understood? Everybody understood this? Is that clear, everyone? Everybody understood this? Is that clear? Have you got now some understanding? Let me know by putting up yo in the chat box or by typing clearo in the chat box. Yo or clearo. Yep, very good. Excellent. Now, let's see if you can visualize this. This is a graph of position versus time. Ignore that P, guys. This was not supposed to be P. This, or think of P as position. Okay, P is position, this is time. Do you see the position graph is constant? That means Champa is just standing there. Time passes by, but position does not change. So she is stationary. Okay, great. Here, look at this. Crazy. Time did not go ahead, time did not go behind, but Champa was there everywhere. What the hell? Not possible, guys. This is not possible. Not possible. You are everywhere. Guys, this is only possible with God. Understand this. Okay? So you are basically everywhere in this question. This means you are here also, here also, here also, and at the same time. At the same time. So hence, this is not possible. You have infinite velocity. You are there everywhere in that universe. Yes. Flash type. Yes. That is position. So somebody, Anamika, understand here the position is not changing, bacha. The coordinate is the same. That's why the particle is at rest or velocity is 0. Here this is not possible. Not possible only. Impossible. Here you can see with the time, what is happening? The position is increasing. So the particle has uniform velocity. As time passes, the particle's position also changes. Understand? So as time passes, the particle's position changes. So there is uniform velocity because this is a straight line. Great. Now, just like you have position time graph, you also have velocity time graph. Now, just like position time graph tells you, oh, at this time, she's here. At that time, she's there. Oh, at this time, she's now here. Same way, velocity time graph will tell you, at this time, this is her velocity. At this time, this is her velocity. At that time, oh, that's her new velocity. So it tells you the information about the velocity. That's what velocity graph is. Now, some of you might remember this from your earlier grades. Remember, the area under velocity time gives you the displacement. Very important. The area under velocity time. So if you have a velocity time graph and it is something like this, the area of this gives you displacement. Keep this in mind. This is velocity versus time. Very, very important. And the slope, how fast, what is slope and all that, I'm going to talk about it in the future classes, but slope is basically the steepness, how steep it is. Okay, so if you have a graph which is like this, this has got small slope, and if the graph is like this, it has a large slope. Understand that. Slope is the steepness. More the graph bends like this, more the steeper it is, and more is the acceleration. Yeah, I hope this is clear. Chiranjeevi, Umang is a session, is a series not on this channel. We are going to call it something else. The name will be revealed very soon to all of you. Okay, so the name of the 11th standard series. This is the bridge course, which is the most important course before your actual classes started. Remember, a lot of people do this mistake. They think or they feel that I should directly start with the 11th standard portion. That's where most of the people feel like giving up completely. Because you won't remember things from 9th standard, 10th standard so much. Plus, there are a lot of additional things in maths and visualization wise and kinematics wise and equations wise, algebra wise, trigonometry wise, you need to know before you actually start the 11th standard physics portion, or for that matter even maths portion. That's why we at JEE Enthuse are doing this only for you. We could have directly started, but remember, we are taking this extra pain, this extra effort only for you guys. Yep. Okay. So look at this graph. Look at this graph. Velocity is constant. So the particle is moving constant velocity. This graph, my God, look at this graph, guys. At the same time, you have all velocities. I have 0 also, I have 2 also, I have 10 also. This is not possible. Infinite acceleration. It is not possible. I have mentioned it clearly. And in this graph, velocity changes uniformly. So basically, this is constant acceleration. You can see this. This is constant acceleration. Velocity increases at a constant rate. Okay, great. So here is the first question coming up on your screen. The graph shows position as a function of time. Position, time. Time on x-axis, horizontal. On vertical axis, the particle's position. This is 2 meters, this is 1 second, this is 2 seconds, this is somewhere in between. Then, during which time intervals is the object at rest? First, second, third, or more than one? Hello Snehasha, welcome aboard. अभिजीत भाऊ आमचा कोर्स जो आहे ऑलरेडी आहे मतलब you already have my micro courses in vPro, and my long-term courses might take some time, but Shimon sirs and Wazim sirs is going to start next week and the next to next week. And the best part about vPro is you can select whichever teacher you want. So in chemistry, let's say you want to select this teacher, you can select that. In maths, you can select some other teacher. You can choose your teacher. So that's the best part about it. Just 1 to 2. Hello Shankar, welcome aboard Shankar M. Okay, so well, the correct answer is from 1 to 2 seconds only. So guys, if you notice, in this duration, the value is same. The value of x is same. So the coordinate did not change. The particle did not move. So it is at rest, because the question asked was when is it at rest? Yes, that's the answer. Beautiful. Let's see the next question. Now, let's have a look at this. It's very interesting. My God, somebody said Asami. My God, who was that? Shamina Nasrin. I don't know Asami. Yaar. I'll learn very soon. Okay, don't worry. Okay, chalo, let's see this. Okay, so define the average speed and velocity for the first 100 seconds. Let's see this. What's the average speed and average velocity for the first 100 seconds? Guys, this is a bumper problem. This is super duper question. If you can solve this, you guys are genius. At this time, if you're a 12th standard student, it might be a little bit easy for you. Let's see who can give both the answers. Let's see who can give both the answers. What is the average speed? This is position, this is time for this particular motion. Come on, come on, come on, all my warriors, quickly. Come on, think. Oh, Abhijit, I know. Okay, don't worry, bacha. Abhijit, just enroll in some course for now. Enroll in any physics teacher's course. It's okay, because all physics teachers are good out here. So whenever my course starts, then you can enroll in my course as well. For now, start. Don't wait. Don't delay. Okay, because the portions will otherwise be lagging. You might have some backlogs later on. Okay, cool. Let's see. Some of you are saying 0.4. Okay. Now, let me tell you guys, the answer is not so simple. See, try to visualize this. Okay, let me draw a number line first. Number line. This is my number line. This is x equals to 0. This is x equals to 40 meters. This is my x-axis. Now, initially, this is my Pandu. Where was he? At time is equal to 0, the position was also 0, correct? When was this? At t is equal to 0, correct? Now time passes by, and after some time at t is equal to 60, where is he? At 40 meters. So this is where Pandu is at t is equal to 60 seconds. At t is equal to 60 seconds. After some more time, definitely Abhijit, I'll do that. Hello Anushka Tripathi, welcome aboard. After some more time, at t is equal to 100 seconds, where is he? He comes back to the origin. Achha, this is where Pandu is, and this is where t is equal to 100 seconds. Guys, quickly answer this part. What do you think is the displacement of Pandu? From 0 to 100 seconds, what do you think is the displacement of Pandu? Answer in the chat box. Hi Shweta, welcome aboard. Abhishek says 0. Yes, good to see Pandu again. 0. Samarpita, Anamika, Archana. Excellent. 0. Beautiful. Displacement is 0. So average velocity, remember, was displacement by time. Now if numerator is 0, obviously the answer is also 0. So average velocity is 0. Okay, so this part is done. Average velocity is done. Beautiful. Now comes the more tricky part. Average speed is distance divided by time. Think carefully and answer this. What's the distance traveled by? Distance traveled by Pandu. Oh my god, Ankit, that is very shocking news, yeah? I really pray for Neha ma'am and her whole family who has been affected by COVID. I mean, it's really bad. I really pray sincerely from the bottom of my heart that COVID should not be there. In fact, it should get totally eradicated. We should all get vaccinated. We should take care precautions. And I really hope those of you who have been affected, or those families, your teachers, your brothers, sisters, your family members, your relatives, your friends, anybody who is affected from it, my sincere prayers to for all those families. And I really hope God empowers all of you and recovers all of you very quickly. Trimbak, I am very good. All right, 80 meters, correcto. It's not 40 or 140, it is 80 meters. Why 80 meters? Pandu went from here to here, correct? How many meters? 40 meters. He came back plus 40, 40 plus 40. So 40 while going here and 40 while coming back. So guys, a lot of people make that mistake. So the answer is 80 meters divided by time is 100 seconds. So it is 0.8 meters per second. Understand that. Is that clear? Yep, that's the answer. A lot of people make that. Okay, great, great. Clear? Very good, very good. Excellent, guys, excellent. So that's the answer, guys. Okay, now this is your homework question for today. This is your homework question. An object is projected upwards with this speed. What is the total distance traveled before it strikes the ground? Drop the answer in the comment section. Do not forget, yes, if you post it, then I will definitely show your comment next time. Yes, I'm going to do that. Yeah, do not forget that. And for those of you who still do not know about Vedantu, let me give you a brief history and also some of the achievements we have encountered, we have got the last few months. So first of all, JEE Mains was conducted in February and March for all the 12th standard students, and Vedantu students have done exceptionally. In fact, 1 in every 2 students has already got qualified for JEE Advanced. 1 in 2 Vedantu students, that's like 50% of the students. And there are 11 students in physics, 6 students in maths, and 2 students in chemistry who have got 100 percentile in the respective subjects. 100 percentile in JEE Mains, that's huge. And the number of students above 90 percentile, look at that, 686 students, above 99 percentile in JEE Mains, 307 students. You can truly see this is now the new topper's address. It's not quota anymore, it's at your house. You don't have to travel anywhere, you just can study from the luxury of your home. So guys, the pro subscription batches are going to start. Now, when are these going to start? These are basically your long-term batches. Okay, these long-term batches will start, so they will start on 26th April, all right, that's today, and also next week as well, and maybe in the second week of May as well. Now all these batches are available in English as well as Hindi, both the options are there. And if you miss also, you can watch the replays and you can revise those same classes again and again. The replays are available as many times as you want. After every class, you will get assignment. This is after every class. So after every class, very, very important, you will get assignments and there will be lots of questions plus tests are also a part of it. And you'll also be getting lots of micro courses. Let's say for KVPY preparation will start soon, and all the Olympiad preparation will also start soon, and a lot of my micro courses. Yes, you're going to find Shreyas Sir over there in lots of micro courses, and you will also get detailed report cards for all the tests and assignments that you are going to submit. So all of this is available at a very, very affordable rate, because normal coaching fee is around 2 to 3 lakh rupees. But at Vedantu, your pro subscription offer starts from hardly 53,999 rupees after the discount when you use the coupon code SHHPRO. Yes, so look at this price, guys. I mean, this is not 68,699. It's just this much for 2 years. Not 1 year, guys. Read this carefully. This is 2 years. Your normal coaching fee for 2 years will be at least 3 lakhs. At least 3 lakhs. Minimum. And if you go to quota and other things and you join few things more and all that, minimum 4 to 5 lakhs. And this is almost 1/10 of the price. And there is a higher subscription also where you get doubt solving. So whatever you get here, test series, live interaction, plus doubt solving in classic version. And if you want more, everything, doubt solving plus personal teacher, that's what you get in plus, and that's for 1,19,999. Again, when you use the coupon code SHHPRO, that's an amazing offer. Do not forget to check it out. And if you still have doubts, please message me on my Instagram handle, which is Shreyas_Vedantu. It's already there below. Okay, all of this, if you calculate per day cost, trust me, it's almost the cost of your meal per day, not more than that. Yes, the amount you spend on your food is probably more than the amount you will spend at Vedantu in this pro subscription. All right, so guys, I'm really hoping to see many of you out there. And what will be the name of the 11th standard batch? Samarpita will let you know soon. Don't worry about it. Hello, French fries. You making me hungry. Ajay, bye-bye. Shivani, bye-bye. Okay. Oh, very good news. That's Ankit. Glad to know that. Bye-bye, Neha. Take care. Hasta la vista, everyone. Bye-bye, Nikhil. Thank you for all the love from Kerala. Assami actor. Well, Shamima, please ping me some Assami actors and dialogues. I'll definitely rehearse it and come, okay? Okay. Bye-bye. Take care. And Shikhar, what do you want to know? Sir VT, I'm not sure what you mean by that. Shikhar Maurya, please, you can ping me on my Instagram handle or leave a comment below, and do not forget to post the answer of the homework below. Bye bye. Take care, Akshita Golmalu, Srinu, Shikhar. Take care, guys. Hasta la vista. This was Shreyas here. Good night.